Incoming EC Web Setting Tutorial. Tutorial video number 11. Power meter settings. Power meters readings will be used by ECPv2 controller for the calculation and power references for the site control function. Power meter values can be read via Modbus RTU communication or Modbus TCP communication. The settings options has to be edited in the EC web for both type of communication. In order to establish communication between connected single or multiple power meters and ECPv2 controller, the baud rate and parity has to be matched correctly on both devices, which means your power meter should be on the same baud rate and parity as your COM port 2. Further, you need to name the ID of the power meters, which is the Modbus address of power meter to the ECPv2. How to set ID address of SPM33 power meters. Please watch the following video. Enter the menu. Then use sibling menu switch to reach the address. Then confirm the editing by pressing Enter menu key. There you have to type the password 01 by using sibling switch and confirm. Then you will lead to changing the address. There you have to use sibling key to change the ID and press confirm. There you have changed the ID. Now you can exit the task. Next you have to set the baud rate of your power meters. Please follow the next video instruction for your guide. Enter the menu and reach the baud rate by using the sibling menu switch. When you reach baud rate, press confirm key to enter the edit mode of baud rate. Then you have to enter the password and confirm. And then you will lead to the baud rate editing option, where you have to use sibling key and confirm your selection, and you can exit the task. SPM33 power meter has no parity one-stop bit default party setting, which will be used in EC Web COM port 2 setting. The power meter need to see the voltage and current in order to calculate power and energy. Before connect the high voltage grid or genset or PV to the power meter, it has to be step down its feeding to the power meter. By changing the CT and PT, the power meter will see the reduced value of the current and voltage. The following session will demonstrate how to change the CT and PT ratio. How to change the CT2 ratio on a SPM33 power meter. Press the menu button and use the sibling switch button to reach the CT2 editing. Then press menu button and enter the password by using the sibling switch and change CT value. How to set the PT ratio on a SPM33 power meter. Press the menu button and use sibling button to reach the PT ratio editing. Then press menu button and enter the password 01. Then use sibling menu and switching sibling menu to change the ratio. Once the ratio entered correctly, press the menu button to save the editing. How to change the PT value on a SPM33 power meter. Press the menu button and use sibling switch to reach the PT2 value editing. Then press menu button and change the password by using sibling switch button. Then edit the PT2 value by using switching sibling menu and sibling button. Once the editing completed, press the menu button to save the editing. What is the difference between SPM33 V1 and V2 power meter? The V1 type is 5 ampere current in the secondary circuit and the V2 is 2 ampere current on the secondary circuit. Once you have done the SPM33 settings, go ahead and edit the EC Web power meter setting in order to establish communication between power meter and ECPv2. There you have to make the setting for all connected power meters for PV genset and grid connections separately. Power meter settings depends on number of connected power meters and Modbus RTU or TCP connection. Let's assume this is a sample site, and here you can see there are 3 SPM33 power meters which are named ID1, ID2 and ID3 connected to PV plant genset and grid via Modbus RS485 connection. Modbus ID numbers always should be named in a sequence manner. For example 1, 2, 3 or 11, 12, 13. Let's find out how to do the power meter settings to this connection. Let's open the setting of the EC web and select the COM port 2 and click on the PV settings. Before move to PV power meter setting, you have to set the COM port baud rate and parity setting same as SPM33. Please use video tutorial number 7 for COM port RS485 connection setting. Then click the power meter icon to edit power meter settings. There you have to click edit button. Here you have to select the pilot SPM33V1 type for IncoMe product. If you are using a different brand, use this arrow button to find your power meter type. IncoMe supported power meters are found on this list. Next you have to select the Modbus type, which is RTU communication. Next you have to edit the ID number of the PV connected power meter, which is ID number 1. Ignore the IP settings and sequential ID editing because this option is applicable for TCP connection only. Next click the number tile, which setting means how many power meters are connected on this ID. As you have connected a single power meter, edit it for 1. Again ignore TCP RTU converter and save your editing. Now you have done the power meter settings for the PV connection. Maximum of 16 power meters can be connected for PV communication. Repeat the same setting for both genset and grid with ID number 2 and ID number 3. Let's do the setting for genset power meter connection. Maximum of 16 power meters can be connected for genset communication. Let's complete the grid power meter setting. Maximum of 16 power meters can be connected for grid communication. Now you have completed all 3 power meter connection setting for RTU communication for PV genset and grid connection. Let's see how to do the setting for TCP communication in case if a site connected with power meters which use TCP communication. The IP addresses of power meters has to be in same IP sequence of IncoMe controller, and the IP address has to be in a sequential manner from low to high. For example, see the sample IP on the illustration. Then go to the setting and select PV for PV connected power meter and select the power meter type, and communication type will be TCP. Here you have 2 way of setting. You can use either sequential enabled or disabled. When sequential is enabled, then the Modbus ID set is used with the lowest IP and increment together with the IP sequences. Let's see the EC web setting for above mentioned connection. Let's see how should be the setting for the second power meter on the PV connection. When you do this setting, the ECPV2 controller can identify the power meters by using IP address or ID numbers. The second way is IP sequence disabled setting. When sequential is disabled, then the Modbus ID set is used for all the IP addresses. Let's check how to set the setting for this situation. Add the first meter. And add the second meter, which has a non-sequential IP address. The same way you have to do the setting for the genset connection and grid connection separately. In case interfacing with Modbus TCP to Modbus RTU meters via a TCP RTU converter, then the converter setting must be enabled. The IP address to be set equal to the converter and the Modbus IDs are used in the TCP frames from the ECPv2 for identifying the individual meters. Let's see how to do the setting for this kind of installation. Do the setting by starting to select your power meter version and change the TCP type. Then add the ID number. Finally, you have to enable TCP RTU converter. Now you have learned about power meter setting for PV genset and grid connection. In short explanation, you need to set your power meters for ID and baud rate for RTU communication. Then you need to do the COM port 2 settings for baud rate and parity. Then you have to do the power meter settings for PV genset and grid connection. If your site uses TCP communication, you will do the settings for TCP connection. Thank you for watching the video. This video presented by Nkumi. For more information, please visit our website www.mcomb.com.